Oh, hello Adya. I'm doing well. What about you?
I'm also fine. By the way, how is your studies going? Which topic is going on in your maths class?
Oh, in our maths class, the topic mensuration is going on, in which we are studying about the volume of different solids.
Oh, the same topic is going on in our school also. Today, our teacher taught us about the volume of a cone. But the problem is that I didn't understand the formula for getting the volume of a cone.
Oh, is that? Our teacher taught us very nicely. He even demonstrated it for us using the maths kit provided by PM Shri initiative. And I understood it very well.
Demonstrated it? How did he even demonstrate the volume of a cone?
Yes, he did it using a cone and a cylinder.
Oh, I wish I could also see it. Maybe then I'll be able to understand the concept better.
Don't worry, if you want I can demonstrate it for you, as now I have the cone and the cylinder with me.
Really? You have it right now with you?
Yes, I do.
Oh, then can you demonstrate it for me now?
Sure, so now we are going to understand the concept of relationship between cone and cylinder with the help of the kit provided by PM Shri initiative. Are you ready?
Yes.
Well, before that, can I ask you a question? What do you mean by a volume?
Oh, that's a simple question. Everybody knows the measurement of the space occupied by an object is known as the volume of that object.
Yes, you are right. The volume is just the space occupied by something, let it be a human, object or anything. So now let me show you something that will help you understand the topic better.
Yeah, please.
So, I'm going to demonstrate the activity for which we are going to use the cone and cylinder of same base, height and radius. So, the activity is very simple. Firstly, I'm going to fill the cone with water. So, I'm going to fill the water and transfer it down in the cylinder. So now tell me Adya, what do you notice?
Well, only a small portion of the cylinder is filled.
Yes, which means that we have to continue the process until it's completely filled. Now let's do it once again. Do you notice any change?
Yes, now more portion is filled than the first time.
Then let's try again. And do you notice anything?
Yes, now it's filled up to the brim.
Yes, so what we have seen is that the volume of a cylinder is thrice to that volume of a cone.
Oh, so the volume of a cylinder is thrice the volume of a cone with same base and height?
Yes, that's why the volume of cylinder is pi r square h and the volume of a cone is 1 by 3 pi r square h.
Thanks Abhinaya. Now I completely understood this topic. The PM Shri Maths kit really helps.
10 cube centimeter, then what would be the volume of a cylinder? Anybody can answer it? If the volume of a cone is 10 cube centimeter, then what is the volume of a cylinder?
10 cube centimeter. 30.
Yes, that's right. This PM Shri Maths kit is making me more interested in these topics. Do you guys have anything more with you?
Yes, I have some other materials like squares and triangles to understand and demonstrate Pythagoras theorem.
Oh, in my next chapter, there's the application of Pythagoras theorem. Can you tell me more about it?
In mathematics, Pythagoras theorem is a fundamental relation in Euclidean geometry. This helps us to find the longest side of right triangle and used in many real-life situations. This theorem is named for the Greek philosopher Pythagoras, born around 570 BC. The theorem has been proved numerous times by many different methods. The Pythagoras theorem states that in a right angle triangle, the square of the length of the hypotenuse is equal to the sum of square of the other two sides. Pythagoras' theorem has become a fundamental concept in mathematics. It has numerous applications in various fields, including building design, constructions, travel, surveying, and computer graphics. For a better understanding of Pythagoras' theorem, let me demonstrate it to you.
Now children, in the interaction board you can see the demonstration of Pythagoras theorem, and you all know that the square of base plus square of height is equal to square of hypotenuse. So you can see the square of the base on one side, one square is kept there, then square of altitude, height, there it is kept, and the hypotenuse, that means one side is taken as the side of the hypotenuse is taken as the side of the square. Yes, that's all.
The formula is altitude square plus base square gives hypotenuse square.
Yes. Hope you all understood. Thank you.
Good morning, everyone. We have seen the basic concepts of maths. Now let's talk about something more complex, that is trigonometry functions. Today I am going to be talking about the two most important mathematical functions, that is sin x and sin inverse x. Let's start with sin x function. This function, central to trigonometry, gives us the ratio of the opposite side to the hypotenuse of a right angle triangle based on an angle x. The graph of sin x forms a smooth periodic wave that oscillates between -1 and 1, repeating every 2 pi units. This wave-like behavior is crucial in various fields of science. For instance, in physics, sin x is used to describe the wave motion such as sound and light. In engineering, it models alternating current models. And in astronomy, it helps calculate the positions of celestial bodies and forces of tidal waves. Next, let's consider sin inverse x. The inverse sine function, also known as arcsine, unlike sin x, sin inverse x takes value between -1 and 1 and returns the angle x whose sine is that value. Its graph steadily increases from -pi/2 to pi/2, reflecting the relationship between angles and their sine values. Sin inverse x is widely used in physics and engineering to solve the problems where determining angles from known ratios is necessary. It is also crucial in navigation and geography, where angles of elevation and depression, and in medical imaging techniques like MRI to construct images. Now, here's something fascinating. If you take a closer look at the graphs of sin x and sin inverse x, you'll notice something interesting. They are mirror images of each other. If the graph of sin x across the line y is equal to x, you get the graph of sin inverse x. This symmetry happens because sin x and sin inverse x are inverse functions. Sin x maps the angle to a ratio, and sin inverse maps the ratio back into the original angle. The mirror images beautifully illustrates this deep connection. In conclusion, sin x and sin inverse x are not only important in mathematics, but also play a critical role in other fields of science like physics and engineering.